Welcome everyone. In last video we have seen the introduction to the counters. What is the need of the counter? What are the different application of the counters? In today's video we are going to see the different classification of the counters. Counter can be classified into few categories based on their design process and based on the application. First, we are going to see how we can classify the counters based on their design process. First, on the basis of design process, the counter are of two types. One is a asynchronous counter and it is also called as a ripple counter, and second one is synchronous counter. So what is asynchronous and what is synchronous counter is we are going to see with the help of an example of 3-bit asynchronous counter. We will see why it is called as asynchronous counter. In this case, I'm using 3 flip-flop because it is a 3-bit counter. It can count from 0 to 7 because 0 can be represented 0 0 0 and 7 can be represented as 1 1 1 in binary. So this is the maximum number which we can represent with a 3-bit binary. So I have flip-flop 0 which is LSB, flip-flop 1, flip-flop 2, which one is the MSB. We will pick the output from Q0 which is the output of the first flip-flop, Q1 which is the output of the middle flip-flop, and Q2 which is the output of the last flip-flop. We need to focus on the asynchronous term first. See, the clock of first flip-flop is connected with the circle clock right here, but the clock of the second flip-flop is connected with the complementary output of the first flip-flop from here. As same, the clock of the last flip-flop is connected with the complementary output of the last flip-flop. We can also connect them from output of the second flip-flop or the output of the first flip-flop, but that will change the circuitry, that will change its working. We will see it later. So this is the timing diagram. This counter is a kind of up counter. It will show you 0 0 0 in the first clock, then it will show you 0 0 1 in the second clock, then it will show you 0 1 0 0 1 1 and so on. Right? So this is 0 1 2 3 4 5 6 and so on. This is the example of 3-bit asynchronous counter. What you need to focus here is that what is the arrangement of the clock and the input connection for the asynchronous counter. Let's see the example of a synchronous counter. This is the example of 3-bit synchronous counter. Again, I'm going to use 3 flip-flop, flip-flop 0 which is LSB, flip-flop 1 and flip-flop 2. As you can see in this circuit, the clock of first flip-flop, clock of second flip-flop and clock of third flip-flop are connected to the same clock circuit. It means all 3 flip-flops are going to be triggered at the same time. Each flip-flop is a kind of positive as trigger flip-flop. This is a positive as trigger flip-flop, or this is a positive as trigger flip-flop. So that is the major difference in asynchronous and synchronous flip-flop. In case of asynchronous flip-flop, like here, the clock of first flip-flop from the circuit, the clock of the next flip-flop is from the previous flip-flop output or the complementary output. The clock to the next flip-flop is the complementary of the previous flip-flop or the output of the previous flip-flop. But in case of synchronous one, all the clocks are connected simultaneously. Next, we are going to summarize the difference in synchronous and asynchronous counter. As ripple or asynchronous is one of the same thing. The first thing is the output of the first flip-flop, which is also a LSB, which represents the LSB bit of the circuit, will act as the clock for the second or MSB flip-flop, and so on. So on means the output of the second flip-flop will act as the clock for the third flip-flop if it is present in the circuit. On the other hand, in synchronous counter, there is no connection between the output and the clock of any flip-flop. Second, we can see in case of asynchronous counter, due to this, in asynchronous counter, the flip-flop are not triggered simultaneously or parallel. In case of synchronous counter, the flip-flop are triggered simultaneously and parallel because the clock is same for each and every flip-flop. The last but not the least difference is the design process of asynchronous counter is easy. If we want to extend the circuit of the asynchronous counter for higher order counters like 3-bit counter, 4-bit counter, 5-bit, 6-bit, 7-bit, it is very easy. But the design process of synchronous counter become more complex and lengthy for the higher order counters. This point you will understand in the upcoming videos when we will see the designing of the synchronous counters. We can also classify the counter on the basis of application. This thing we have also seen in the last video. That counter can be called as up counter, that which can count 1, then it will show 2, then 3, then 4, and so on. The down counter, which will start from some number n, and then it will show the value n minus 1, n minus 2, and so on. In up down counter, it can count in both the direction, upward as well as downward. The random counter, they will count in some random sequence. The mod counter is also a kind of a fixed number counter. We will see the designing process of the mod counter also in the upcoming videos. Even number and odd number counter, or some specific sequence counter. So we will see how we can design these different kind of counters in the upcoming videos. In next video, we will see the working of the 4-bit asynchronous up counter, and we will see the working of the 4-bit asynchronous down counter. Thank you.